Alright, so let's have a look at atomic absorption spectroscopy. It's a quantitative way of measuring how much of certain ions we have in solution. Alright, so what is spectroscopy itself? It's the study of the interaction of electromagnetic radiation with matter. So basically, when we vaporize, different elements absorb, so when they are vaporized, so as a gas, different elements absorb different frequencies, and they are very, very specific to each element. So if we look at our emission and absorption spectra, so this is the continuum of all visible light, and we can see that we can identify each atom by its emission spectra. However, absorption spectra is the same sort of thing. So if we were to shine continuous light through an element, okay, that is a cold gas, it will absorb certain bands of light. And you'll see that this one here is going to absorb, so it's the same gas here, right? So this one here absorbs the same frequencies that it emits. And the reason is that your electron here, when you heat up this hydrogen atom, this electron moves up a state, then comes back down, and as it comes back down, it releases that energy as light. Okay? When we're looking at absorption spectra, what we're actually looking at is we are just looking at so when the light comes in, what we're observing is just the frequency of light that is absorbed as that electron raises up a level. We're not looking at what happens when it drops back down. So you're going to talk about both of these ideas. And here is the difference. So in this case, we pass light through a sample and we have a look at which bands are actually absorbed. Whereas in atomic emission spectroscopy, we heat up a sample and we look at which bands of light are emitted. And you'll see you get this kind of picture here where you get one or two bands of light emitted. And in this one we'll have a few bands, the continuous spectrum with one or two bands that are black, that are absorbed. So what actually is it? It's a quantitative technique, and we use it to identify the presence and concentration of substances. So it can be quantitative and qualitative. And we analyze the spectrum of light that's going through, and we see which colors don't make it out the other side. Because your vaporized sample will absorb certain frequencies. So AES is really useful for detecting concentrations of metal ions in solution. And we perform it using an atomic absorption spectrometer. So how is it done? And these are the steps. So you've got a hollow cathode ray lamp here, and the cathode itself is made of the metal being tested. This means it emits light of a certain frequency. So if you're testing for tungsten in your water or lead, the cathode will be made of just tungsten or lead. So the light produced by the lamp is then passed through a vaporized sample. So you've got a sample here that's been heated up and vaporized, and as it travels through that, it absorbs a certain amount of light. Now, it will only absorb the light from this lamp, so it's only going to absorb it if we have cathode made of metal A, and this is vaporized sample A, it's only going to absorb it if the metal is present here. Now, the amount that is absorbed is proportional to the concentration. So if you've got a really dilute concentration here, only a small amount will be absorbed because there's not many atoms to absorb it. If you've got a very concentrated sample, you'll absorb lots of that light. So the intensity of the light that passes through the flame is measured by a photomultiplier tube down here. Okay, so that means it can take a really weak signal and amplify it. So a photomultiplier is the same as an amplifier. We can then compare the intensity of the light that's absorbed with a standard sample. So what we're measuring here is absorbance. So the amount of light that is absorbed as it goes through. If it is a high level of absorbance, okay, then there is a high concentration. If there is a low level of absorbance, there is a low concentration. So how do we measure that? First, we have a bunch of dilute standards, okay? So we know the concentration exactly, and we run these samples through the AAS. And this gives us a calibration curve. And you'll see that it's a straight line. It will curve at higher concentrations, even the calibration curve. It will cause a curve because you get interference from each atom, as there's just too many of them around there. So we make a calibration graph, which we go, all right, so here is sample at 5 micromoles per liter, and here is a sample at 10 micromoles per liter, 15, and blah, 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 and we go along, and then we graph those out. So the standard solutions will produce a straight line graph until we reach higher concentrations, in which we'll start to get a slight drop-off curve. We then measure the absorbance of our standard, okay? So our standard might give us an absorbance of 2 units, 2 absorbance units, which means if we go along here, we can go, all right, it is, and our graph would be much more specific than this, but we can tell it would be a 22. So our sample is 22 micromoles. All right, I hope that made a lot of sense. That's AAS in a nutshell. If you have any questions, put them in the comments below, and we'll get back to you as soon as we can. Thanks for watching. Bye now.